Hi, welcome to the channel. We are continuing our integration series, and the playlist which contains all of the videos of this topic is in the description down below. Okay, today we have an integral of arcsine of x squared dx. The first thing that came to my mind was to write, make the substitution of u is equal to arcsine of x. Then in this case, du would be dx over square root of 1 minus x squared, and then we can do the replacement, like this integral would be equal to u squared times, dx in this case is du times 1 minus x squared in the square root, so it's just 1 minus x squared in the square root du. Now we need to eliminate this one so that we can have all the variables in u or in x, doesn't matter. So to do this, we can use the inverse sine substitution, and in this case we would take x as sine of theta, and dx would be just cosine of theta d theta. Now here I thought, okay, we can of course change x to theta in this case, but we'll need to change u as well, like u and du. So because of this, we'll need to go back to the definition of u, how we defined it. So I saw that, okay, instead of all this, why not to use the inverse substitution directly? Like, of course we can go on in this way and find the value of u in terms of theta, but it's rather long, and if we can do this directly, no need for side steps. Alright, now after this small analysis of the process, we can just directly write that we'll use inverse sine substitution. So in this case we have, let x is equal to sine of theta. In this case dx would be just cosine of theta d theta, and if you take the arcsine of both sides of this equation, we can also get that arcsine of x is equal to theta, like arcsine of sine of theta, which is theta. Alright, now that we have main equations in our hands, we can proceed to our initial problem and put the values into our integral to solve this. Okay, so this integral is equal to, first remember, arcsine of x is theta, so we have theta squared. Now dx is cosine of theta d theta. Great, now we have a structure that we're already familiar with. It's a polynomial times some trigonometric function, and in these cases we can just use integration by parts to reduce the degree of the polynomial, and well, the trigonometric function will just alternate while the polynomial will turn into the one, so we can just find an integral of that trigonometric function. Okay, enough of words, let's see how we can apply the integration by parts here. I'll make the brackets as usual. So of course we want to reduce the degree of the polynomial, and for this purpose, we take u as theta squared and dv as cosine of theta d theta. Well, in this case, du will be 2 times theta d theta, and v will be, what, sine of theta, right? Like the derivative of sine of theta is just cosine of theta. All right, and we want the form of, remember, uv minus an integral of v times du. Right, it's just a small tip for you. Okay, having this in our hands, we write u times v is theta squared times sine of theta minus an integral of sine of theta times 2 times theta d theta. Now, writing this in a more neat way, we have just theta squared sine of theta minus 2 times an integral of theta times sine theta d theta. Now, as expected, we have reduced the degree of the polynomial by 1, and now we have a similar structure of polynomial times trigonometric function. We'll apply integration by parts one more time, hopefully the last one. And alright, somehow instead of writing theta here, I wrote sine square, and sine square of nothing actually. Okay, let's correct this. It's theta squared times sine of theta minus this thing over here. Okay, I'll apply integration by parts one more time, and of course we don't need to rewrite the whole process that we did here. Instead, we'll try to do this in our minds. We have a polynomial that we want to find the derivative of, and the function we'll search for an antiderivative of. Okay, minus 2 times, I'll open up the brackets for convenience. So we want to reduce the degree of the polynomial. For this, we just rewrite it because we don't touch it in an earlier stage of integration by parts. and multiply this by an antiderivative of sine theta d theta, which is indeed minus cosine of theta, right? Then we have minus an integral of, we just repeat what we found, which is minus cosine of theta, and we multiply this by the derivative of theta itself. So this will be just 1 times d theta. Alright, we're almost done with our problem. Now let's clear it up a little. So in this stage we have minus minus, which is plus, so plus 2 times theta sine of theta, sorry, cosine of theta. Then we have minuses here, which is plus and minus in the end, so we are left with minus 2 times an integral of cosine of theta d theta, and that's it. So let's rewrite this. And in this stage, we already know that the integral of cosine of theta d theta is just sine of theta. And since we are dealing with an indefinite integrals, we need to add the constant in the end. Alright, losing the track of what we were doing here, you may think that it's our final answer, but it's not. It's indefinite integral, so we need to express the answer in terms of the variable of a function that we had initially, which was x. So now let's express our answer that we found in terms of x. This would be equal to, well, remember that theta is arcsine of x and x is sine of theta. I think that's enough for finding what we have here. Let's mention it here as well. X is equal to sine of theta. Theta in this case is just arc sine of x, and we also have cosine of theta, which is cosine of theta, which would be just 1 minus x squared in the square root. It's because cosine squared theta plus sine squared theta is 1. There's a subtle detail of these transitions, in particular why it's not like ideally it would be just cosine theta in an absolute value, why it's equal to cosine of theta. I've explained this in the video where I dived into the inverse sine substitution. I'll put the link down in the description below so that you can go there and look how it's done, but for the time being we can use this. So let's proceed. We have arcsine of x squared times x plus 2 times arcsine of x times square root of 1 minus x squared. Not enough space here. Okay, minus 2 times x plus c. And it's already our final answer, but to make it look even better, we can write this in a more neat way. Now this is our final answer. We can leave it as follows. Alright, if you have any questions, feel free to write them in the comment section below. Here is the brief overview of what we did. And see you on the next videos. Bye.